Hi everyone, welcome back to the channel. In this video, I thought it'd be a good time to start doing some layouts since we spent some time on basic setting up of Cadence and also extracting some of the backend offline dielectric characterization. Things like that are finished now. It's a good time to get into layouts. Okay, before we start with layouts, I just want to do a quick housekeeping. If you go to my channel and if you look at the playlists, I made a new playlist called Tape Out.
It's a shame so many people struggle
Sorry.
with the most
Uh,
common teeth.
Unfortunately, I have to watch ads on my own videos as well. Anyways, so if you open the tape out series, you can see I've kind of like ordered things based on how I think you should kind of go through them. So I'll add the video to the series that we're making now. That'll be somewhere maybe on the second or third of this series. So if you haven't seen any of these, I would recommend, if you don't know anything about Cadence or how to set it up, I would recommend starting with the first one and maybe the second one as well, and then getting into the layout video that we're going to do now. Okay, so that's one thing. Second thing is if you go to my website and you go to resources page, I have added this file here, Cadence hotkeys, which we'll be using today. So make sure you take a look at this one. Okay, so with that, let's get started. So what we'll do today is we'll make an inverter and then do a layout of an inverter. And I'll go over the basics of Cadence layouts and how it works. If you've already done layouts before, you probably don't need to watch this. And I'll follow up with the next video where we'll do the DRC, LVS, and PEX. I'll talk about what that is in the next video. But for now, let's just say, okay, we design a simple inverter. Um, we'll do the schematic and then do the layout of it. Okay, so I'll create a new library. I'm going to call it AVM A05 inverter YouTube. And as I mentioned before, I guess once that when you're making a new library, always use some kind of initials. For me, it's AVM for my name, so that you can differentiate and it makes collaboration much easier. Okay, so I'll say attached to an existing technology, attached to GPDK, hit OK. And that's the new library. Click on it and then create a new cell view. And what we'll do is we're going to make a schematic first. On schematic, yeah, AVM inverter cell is fine. And hit OK. Okay, so now we're going to make a quick schematic. If you don't know the shortkeys for schematics, I would recommend going through it here. I think I went through it before already in this video. So if you haven't done that before, maybe watch at least one of these two. Even this one, I think I go through the hotkeys in schematics, so I'm not going to do it again. But essentially, you can hit I and get to instances. So let's set up a PMOS and then an NMOS. Okay, and I'll connect them with a wire, connect their inputs. And then of course, these need to be connected to, the body needs to be grounded for NMOS and going up to VDD for PMOS. And then let's say this is the output and this is the input. Okay, that's it. So now we'll create some pins. Hit P. Let's do VDD and VSS. Set input output pins and then connect them to the wires. Some more pins for the input. I'll set this as input pin and an output pin. Okay, that's it. So that's essentially an inverter, simple inverter. Then we'll create a cell view for this, a symbol for it. So go to create cell view from cell view, and then you can leave it as defaults, hit OK. And let's move VSS to the bottom. So left pin, right pin, top and bottom pins, then hit OK. So it makes a nice symbol for you. Inverter typically has a different symbol, so I'll just quickly show you how you can change it into a triangle. So let's draw a triangle. Yeah, it's a decent triangle, I guess. Okay, so let me actually move these. hit U for undo. I'm going to move all of these. Let me actually just move this away first. So I'll say VSS is here, VDD is up here. And then let's make a circle for the output. It's out of the way. Okay. Let me bring this in, bring this in. Make sure our output is over here. And then we'll move our input out here. Okay. So how do I make this? Just delete that. Okay. I'll call this inverter. Inverter one. All right. Save it. And then let's close it. Okay, that's pretty much it. So now if you see this, you'll have a schematic and a symbol associated with it. Now we need to do a layout for it. Okay, so let's do a layout. Click on this, say file, new cell view, and then go to layout, and I'll use layout Excel. Hit OK, and essentially now it opens up the schematic. We don't need that. Okay, so this is the layout window. So if you've never seen this before, I'll probably go through it quickly. So here we'll do the layout for our schematic of the different metal layers. So on the left, you see here all the different metal layers available in this specific process. We'll go through the ones that we will use later. So let's just set up a simple the schematic, the layout for what we just drew. Right, so I'm actually going to quickly go through all the hotkeys for the layouts. So let's do that. I'll hit I, for example. It's the same as the schematic to create a layout for this. So let's say that's a single NMOS device. I'll place it somewhere here. Okay, and then hit I again. Let's do PMOS now. Make sure you have the same version that we did that we used in the schematic. Okay, so now you can see this is the NMOS and the PMOS. So on the left, if you click on used layers, then we'll see the layers that I used in these two devices or in the layout right now. Let's say you have different layers. I would recommend you go and read about them separately and briefly talk about some of them here. So, you have an N well, so you can click on NV and you'll see only where the N well is. You only need an N well for a PMOS device, right? And then we have an oxide layer, which defines where the source, drain, and bulk will be under the oxide. And then we have a gate in polysilicon, then P implant for the PMOS, N implant for the NMOS, contact layers, and then metal one, which is a first metal layer, and a P-well dummy for the NMOS, right? So those are all the different layers. If you want to know what each of them does, that's a separate video, I would say. You can read about it, or I'll make another video separately about that. But these are the different layers. Okay, and if you go to routing, then that will only show you the layers that are used for routing. So in this case, the contact layer, the poly layer, and the metal layer. So these are the layers above the substrate, above the silicon substrate. All right. So we have source, drain, gate, and body. Again, source, drain, gate, and body, or bulk, I guess. So what we can do is now I'll go through all of the different hotkeys that I just showed you, and then quickly show you how they work. All right. So if you want to make a rectangle, I would say, let's say we want to make a rectangle in M1. Click on metal 1, hit R, and then that'll create a rectangle. Then K for a ruler. So this is, for example, okay, sorry. I hit K, right click, go to options, and then you can change some of these options here. So for example, if I use single, that's usually the one that I prefer. Then it'll just make me a single ruler from here to here, right? So that's 415 nanometers or 0.415, sorry, this is 0.415 microns in length. And that's again about half a micron in width. That's just very small, of course. And if you want to delete uh, all of the scales, all the rulers, then do Shift plus K. And there are other options for rulers. So for example, if I again press K and then right click, go to options, you can make it multiple and you can also make it any angle. So that means that now you can go to any angle and do multiple sections and then double click at the end to get the full length. I prefer the diagonal over the any angle, and that's usually what I use, but many times I will use multiple sections. For example, if I want to measure the length of a meandered line or something like that. We'll use it in the future. Okay, so Shift K gets rid of it. Then if I hit S, I can stretch any of the edges of a given shape. Another important useful tool is A. So if I hit A and I click on this edge to this edge, it'll align them. But for example, click on this edge to this edge, it'll align bottom. I can click on this corner to that corner, or obviously from this corner to even, let's say, this corner. Right? So that's a useful tool too. So I'll select this and hit delete to delete it. Let's make another rectangle. So if you want to move, click on M and then you can move it. Now, which direction it moves, if you want to set that. So for example, here it's only going left, right, up and down and diagonally. You can go to E, click E, that'll open display options. And you can change edit to any angle. Okay. Then this will move in any angle basically. But I prefer to just stick to diagonal, vertical and horizontal. So let's go back there. And I'll change this to diagonal. Okay. So that's about moving. And then if you click C, then that can create copies, for example. P is for creating a path. So that's a path, for example. I don't use that much, but it is useful in some cases, especially in digital design. Then Shift P creates a polygon. Again, these angles are only determined by the diagonals that we set up in the settings just now. And you should stick to that. Don't try to create polygons in any random directions because they won't meet DRC specifications. Okay, so that's a polygon, right? What else? Okay, F. So if I zoom out, for example, by scrolling, I hit F, it fits to screen, right? That's another one. G is just toggling gravity is also a very useful one. So if you go to open this and see if I click G, it turned off gravity. If I go back here, hit G again, it'll turn on gravity. But what gravity does is it snaps to edges and corners. So if I'm very close to a corner, it'll automatically snap to it. See? Even if I'm away. Whereas if G is off, now it's off, then you see even if I'm very close, it doesn't really snap. And this is something that you will actually feel when you play around with it, rather than be able to see it here. So if you click on Shift E, then it'll open layout editor options and you can change here gravity as well. And you can set how far you want the gravity effect to be. So I'll set it to medium and turn it on. All right. Next is O, which creates a via. We'll actually use this quite a lot. So there are different ways to create via. For example, if I want to create a single via between two layers, I'll hit single, and then I can choose the via that I want from M1 to PO, M1 to NVEL, or M1 to M2, but this is just one via it's creating essentially, or between two adjacent layers. So these are the different via options. There are many ways to create it. So you can create it as rows and columns. So for example, here is 1 row and 3 columns. Another way is you can specify the width and height. So I can say, okay, 1 micron width and height of 2 microns, right? So that will create a big via stack like that. You can also select a shape. For example, if I make a rectangle, square like this, I hit O, and then I say shape, and I click this shape, then it will fill that shape with vias. Another option is click O again and draw an area. So I can just draw a rectangle, for example, and that'll create a rectangle with vias inside it. This is very useful. You can also create a stack of vias. So you can say I want to start from M1 and then go all the way to M11, right? And then again, you can choose any of these four options. So let's say drawn area. And I'll make a big rectangle. So now you see it has all the vias. And you can see that by clicking on routing. And now you see it's via 1, 2, 3, 4, 5, all the way up to via 10. And you can view each different layer. For example, this is via 10, via 9, via 8, and so on. And you can even click and drag to enable many of them. So I click here and I drag till there. That'll open up all of them. Okay, so that's how you can create vias. And then, for example, if I only want to look at if I don't want to look at the routing layers, I can go to routing, disable all of them, go to use layers, or rather go to use layers, enable all of them, go to routing, and then disable. So now I only see the use layers without the routing layers, right? And this was already clicked. That's why it's showing. For example, if I go here and I disable it, then it will only show me these, which are non-routing layers, right? Or I can disable all of them in the use layers and then go to routing and then enable all of them. That'll only show me the routing layers. So you can play around with that and see how that works. Okay, so that's about vias. So I'm going to delete all of them. Okay, and then undo, redo, you can do using U. So if I do U, it goes to undo, shift U is redo. So that's again a useful one. And another useful one is tap. So if I click T and then I click somewhere, it will show me what are all the layers at that location. In this case, I have all of these layers, right? I can click here, T, and then click here. Oh, it needs to have at least two layers, sorry. One layer, it won't tap. So here, for example, there are two layers. That's why it was able to tap there. All right, so creating a pin is Control P in layouts, and we'll actually do this later. So I'm going to just skip it for now. You have to set some settings here, which we'll do in a bit. All right, so another very useful tool is this tool called chop or cut. So if I have a rectangle, I can say Shift C, and then I can chop it. So chop it like this, and then chop it like this. This will actually be very useful when we're doing mosaics and layouts in the future where we have grids. If you want to chop out some of the grids or make holes in grids, this is very useful tool. So keep in mind. And then we can also do the opposite of chop, which is merge. So for example, if all of these are overlapping, I select all of them and hit Shift M, and that'll merge all of them. All right, so for example, if I stretch this out, I can also do rotation. So I click this object, hit Shift O, click it again, and now I can rotate like that and set it to any angle. Again, the angles that you use are set by the setting in E, display options, right? Okay. Then descending and ascending into objects. So if you have, for example, we'll use this a lot too. If you have like different sort of levels of design, you can descend into them. For example, this is a P cell, right? If I hit Shift X, it'll ask me if I want to descend into it. For P cell descents, you should be careful so you don't modify it. If you have your own cells and you descend into those layouts, it's fine. That's why it's giving you a warning here, sort of say yes, and now you're into the P cell, right? And that's why you can go into different layers and modify, do layouts at different levels. It's very useful for integration, collaboration, things like that. Shift B goes back. And then obviously scrolling will take you in and out. Then if you press Shift and scroll, it goes left and right. Control and scroll goes up and down. If you hold the left mouse button and select, it selects all of those objects inside that box. Right mouse button and select would zoom into that region. So I can zoom in here, I can zoom in here, and so on. Center mouse button, if you hold and drag, then it actually moves the whole design in place. Okay. And of course, if you want to select multiple objects, so let's say I make many rectangles, I can click Shift and then select all of them. If I want to deselect one of them, I can click Control and then deselect. So for example, if I select all of these guys and I want to deselect one of them, I can click Control and then click on that. Okay. Then Control F will kind of make some of the instances invisible, and then Shift F will bring them back. So this is especially if you bring in layouts from elsewhere from different cells, you can look at what were the layouts you did in this level rather than having to see everything, right? That's also useful at times. And then if you click on something and hit Q, and even the schematic, it's the same. You can change the properties and the parameters of that device. And I think the last two I've already mentioned is E and Shift E. One thing I should mention with E is make sure you don't change this to 0.001. So this is the grid. So, so there are some grids here. You can see it's only able to take certain points. If you make this 0.001, that might cause serious problems when you're trying to do DRC. For example, there are specific grids on which your layout should lie. If it's off grid, they cannot be fabricated and you'll get billions of DRC errors. So be careful about that. Okay, so I think that's pretty much it in terms of the hotkeys. Let's quickly finish this layout. It's very simple. So what I want to do is I want to connect the gates, the drains, and the sources, right? Not the sources, the gates and the drains. So I'll click on poly and then make sure my gravity is on. Gravity is okay. So what you can do is you can just make poly visible. That might make things easier. I'll connect them with a rectangle. And then I want to come up to metal one layer, right? So I'll make a via. So I'll say single via going from M1 to poly layer, and I'll go to row column and maybe make it 3 and place it there. That's good. And the next thing is we want to make a P-well, a large P-well, so that we can connect the body contact, make a body contact for the PMOS. No, sorry, N-well. Since it's PMOS, it's N-well, right? So I'll make a large N-well here, maybe something like that. And then we can bring this using S down there. Okay, and then I'll create a via from M1 to N-well, and I want, let's say, 5 of them. Okay, so let's create it maybe here. And I'll bring these edges back in. So that's creating the body contact. And this needs to go to VDD, right? And also the drain connects to VDD as well. The source connects to VDD as well, right? It's PMOS. So I'll click M1 and then create a rectangle. Create it like that, and then bring this in. There we go. All right, and then that essentially connects the source and the body to VDD. We need to do the same thing down here. So here I'll make a P-well dummy. Actually, you don't need to make a P-well dummy. We can just do directly a via. So in this case, I want to go from M1 to P sub, right? Because there's no N-well, the body of the NMOS device goes directly to the substrate, right? It's essentially the substrate. So we want to connect from the substrate down up to M1 and then connect the source as well. Here. All right, so that's done. And then the last thing is we connect the drains together. Connect these drains. Okay, that connection is good. And I'll also make a connection going out like that. All right, so that's pretty much it. So we've connected the bodies to VDD and ground, connected the sources to VDD and ground, connected the drains together to the output and the gates together to the input. And all of the inputs and outputs and all the connections are now in M1. So we'll make some pins now, similar to the schematic. All right, so when you're making pins, make sure you select VDD. For example, VDD pin is VDD. VSS also is the same. And then select input output and make sure this create label is checked. Set it to manual. Go to options, make sure height is auto, Make sure layer name is same as pin. Layer purpose is also the same as pin. Okay, make sure these settings are selected. Click OK. Then we'll come in here and then make a rectangle and then put the pin name inside that rectangle. And always make sure you're an M1 if you want to make a pin in that layer because it should connect to that layer. Same thing for VSS. Okay, and then Control P again. Then we'll do an input pin, which is of type input, and that goes in here. And lastly, an output pin. Output, this should say out. Right. Okay, that's pretty much it. So that's the layout of our inverter. If you compare it to the schematic, it's actually the same. So you see even here the body or the bulk is connected to VDD. This body is connected to ground along with the source. This is the source connected to VDD. Gates are connected to the input and the drains are connected to the output, right? So this is the basic design and the layout. So next, what we'll do in the next video is that we'll check the layout and make sure it's valid, right? So there are 3 ways or 2 ways to check the layout. So one thing is to check that we've satisfied all the design rule criteria, which is done using design rule check or DRC. And the second way is to check that the layout and schematic match, right? So they have the same nets, the same pins, and so on. And it's very simple here, but when you do big layouts, that becomes very, very critical, right? And that's done using LVS or layout versus schematic check. So once we do those 2 checks, then we'll go ahead and extract the parasitics, right? So since I've done all these, put all these new metals in there, that'll generate a lot of parasitics. So each metal has some resistance and this, 2 metals will have some capacitance between them, and there's also some inductances and things like that, right? So all of those things need to be extracted to see how they will affect the performance of the device. And that's why different layouts will have different performances because um, they all have different parasitics, right? So the schematics may be the same, but depending on who is doing the layout or how you do the layout, it can really affect the performance of your device a lot. So you need to make sure these parasitics are sort of minimized. And that itself is a whole sort of design process is you try maybe a few different layouts and see which is the best performance, right? And that comes with some experience. So as we go through different videos, we'll do that. But in the next video, I'll go through DRC, LVS, and parasitic extraction or PEX. So we'll do those 3 things. We'll incorporate that for this inverter and then check the performance of the inverter, characterize it and see how parasitics have affected the inverter, right? So that process of DRC, LVS, PEX is very important. And we're just using a simple example of inverter right now to just go through it. Okay, so I'll see you in the next video where we go through that. Hopefully this was useful. Thank you. See you in the next one.